My name is Brittany Sullivan with Argyle, and it's great to have everyone joining us today. I would love to introduce our speakers: Jürgen Kramer, Chief Product Officer at Cumulocity; Eric Sander, Vice President, Professional Services at Cumulocity; and Nico Newberg, Head of Product Management at Cumulocity. Welcome all, and over to you.
All right. Thank you, Brittany, and welcome also from my side. So let's get started. And let's start with this acronym, AIoT. So what does it stand for? It's actually a combination of the terms AI, so artificial intelligence, and IoT, Internet of Things. And these things are coming together. In this webinar today, we'll jointly explore what happens if these two powerful technologies, so AI and IoT, are coming together and how you can benefit from the resulting synergies. So I would like to start with a book from Amy Webb and Sam Jordan. And they are talking about, in the book named The Era of Living Intelligence, they state that we are standing at the threshold of a new technology supercycle where AI, robotics, advanced sensors, and biotechnology converge to redefine how our physical world is connected, automated, and made intelligent. In other words, the interaction and intersection of these technologies will push our world into a new phase of technological disruption and transformation, similar in magnitude to the introduction of electricity or the internet. That means it will really disrupt entire industries, cause economic shifts, and also societal changes. So this is a massive opportunity for all of us. The other example I want to give here that AI and IoT are coming together is from Jensen Huang, the CEO of NVIDIA, and he shared his vision in a great keynote and Forbes article earlier this year. He sees a multi-trillion-dollar economy emerging, and he also sees AI evolving from perception AI, which was more about speech recognition and medical imaging, some use cases there, over to generative AI, like digital marketing, content generation. I think every one of us is using already Gen AI day by day. The next step is then agentic AI, and then finally you see it at the top right, the physical AI. And this is then where the AI really hits our physical real world. An AI agent, and we'll come to that in more detail, can use different tools to access different types of data. It can plan, consider context, and these agents can also collaborate with each other. And this allows the implementation and automation of intelligent workflows. For example, in use cases like customer service, something we'll also show to you later. And the last step, physical AI, this eventually means that any machine operation will be optimized by AI. An example use cases are intelligent robots or autonomous vehicles. To summarize, the promise of AIoT is that any equipment will be able to think, learn, and adapt. Cumulocity has been active in industrial IoT for more than a decade. Coming from an IoT perspective and looking at the market, we see the following trends that really push AIoT forward. New regulations like the Cyber Resilience Act and Data Act are pushing secure managed connectivity. So we have more and more devices giving us more and more data, which then can also be analyzed to turn the data into insights and intelligent action. The second trend is the AI trend per se. That's a new technology, a powerful toolbox that certainly can be used in many IoT use cases, but it requires high quality data. Otherwise, you have garbage in, garbage out from your AI models. The second one is the value shift from product to data-driven services, because our society and economies will connect through sharing data in their value chains. And the fourth trend is about next generation software or next generation industrial applications demand real-time intelligence. So there is also older IoT solutions that have been in the market for a couple of years now being replaced with more modern IoT platforms. And despite the promise, most equipment in the field today remains unconnected, unmonitored, and underutilized. Let me give you a rough number. Only 20% of the industrial equipment is connected nowadays. However, distributed infrastructure create complexity. So you have a variety of protocols. In IoT solutions, you have normally different vendors that need to work together. Your IoT solutions are deployed in various locations. That can be a fleet of elevators or wind turbines, or it can be a couple of manufacturing plants around the globe. So it's very important to consider that when you do your rollout. So scaling these things globally in these distributed environments isn't easy. But most importantly, any AIoT journey starts with connected devices. Yeah? Without connectivity, you have no visibility, you have no data quality, you have no foundation for any AI. So what must happen before AI can be applied at scale? And what's required here? And let me show you here in this chart. The first step is really you need to connect the devices and assets. Yeah, so the OT assets. IoT, sorry. IoT is always about connecting the OT world with the IT world. Yeah? And here, the first step is connectivity to the OT world. That means to PLCs, to maybe historians, to various types of devices and gateways. You know? This is normally done through an agent or framework like we have here with the thin edge, and then connects from the edge into the cloud. In the cloud, so the first step is device integration and secure onboarding. Yeah? In the cloud, you then have real-time data pipelines that are able to handle the heterogeneity and also the latency. Let me explain that. You have different types of data coming in here via different protocols with different payloads. So what you first need to do is you need to support different protocols like OPC UA, MQTT, Lightweight M2M, and so on. And then you also need to be able to map the data into your target formats that you need for your applications or in your IoT platform to model then certain AI models. You know? So this ingestion is one important capability. And then also the harmonization, yeah, that you do things like mapping the data to target formats, that you do unit conversions, and so on. The third point here is data contextualization. That means you need to put the data coming from your sensors into the wider context. So is this a sensor, for example, in a wind turbine belonging to a certain wind farm in a certain region? Or imagine you have a production line, right? Is this a sensor from a milling machine, yeah, in a certain production line, in the shop floor of a plant in Germany, and so on? This is very important if you want then to do richer analytics on top. You need that context. The fourth step is then data access. So you need to provide access to your contextualized high quality data so that then your AI agents and applications can leverage that data for their jobs. You know? All of that, as I said, is a distributed setup normally between edge and cloud. Yeah? So you need an edge cloud orchestration, and edge is also required for the latency and timely processing. So what you normally do is you do certain pre-processing steps already at the edge before you send all the data into the cloud. And guess what? Cumulocity is an AIoT platform that provides these capabilities, you know, that provides the secure device and edge workload management, that scales to really large fleets of millions of devices, that allows you this ease or gives you this ease of integration and analytics capabilities out of the box. You know? And with the right platform, your distributed assets become a real-time nervous system for your business. And here is what becomes possible after foundational barriers are removed. Once your data flows securely and intelligently into the platform, you can now use the power of AI and really innovate with your solutions. And there are basically two pathways in which we categorize our use cases. The first one is AI analytics, and that's more the traditional way of using AI and machine learning to analyze IoT data, to generate insights, to automate actions to increase asset performance. The benefits from a customer perspective, if you do that, so if you apply AI and ML to your IoT data coming into the platform, you can enable real-time decision-making, you can improve your asset performance and effectiveness, so OEE-style use cases, you can drive predictive maintenance, you can do anomaly detection, and so on. And that's been around for quite a while, but still very valuable for our customer base. The second pathway is about AI agents. You know, that's more the cutting-edge innovation. Yeah? And this enables natural language interaction and intelligent automation. So for example, with these technologies and the AI agents, you can offer new ways to interact with devices. So you don't need to use APIs or coding or clicks in a UI to interact with the devices. You can simply talk to your devices. Yeah? and also use an AI to get recommendations. You can automate complex workflows, do troubleshooting on certain errors that you see from your devices. And this all enhances the user experience and productivity. And we'll show you now customer examples for both approaches and explain how our enhanced product and service offering helps you to capitalize on AIoT. Now I'd like to hand over to Eric Sander from our professional services team to walk you through the use cases.
Thank you, Jürgen. So, hi, I'm Eric, and thanks, Jürgen, for sharing the overview about our AI use cases. And you hyped us all up about the AI agents now, but let's first go one step back and go to the AI analytics part, because that's still the bread and butter AI use cases for most customers. Because while AI agents are great for interacting with customers or providing operators some first insights into how to react to machine failures, the AI analytics part is really how you can understand your machines, your equipment in a better way in order to maximize its performance. And how does that work in real life? So it all starts, of course, in the IoT world with devices. So your devices create data, and we talk to these devices using OT protocols, OPC UA, but also classics like Modbus or other bus protocols. And usually we try to capture this data in a local gateway. And either this gateway is a real separate hardware box, or it's something that runs in a machine or on a piece of hardware that is already available to you on site. In this box, the data gets then buffered, so you're safe against, for example, internet outages, and it gets structured. And then in the next step, it gets pushed to the cloud, in this case, our Cumulocity IoT platform. In there, you have the usual functions like dashboarding and looking at your data. But here we want to focus on the ML AI lifecycle. So what do you do once the data is nicely structured, harmonized, and available in the cloud? You go for a data export, because data scientists usually do not work directly on IoT data, but they are used to work with data in a data lake format. So we export the data in a data lake. That's usually a data lake provided by one of the hyperscalers, but it could also be a local file storage, for example. Once this data is then available, we provide a standardized SQL access layer to this data, or some data scientists also prefer to work with Parquet files or Iceberg files directly. In any case, data scientists usually have their own tooling and their own preferred way of using this data in order to train models and get insights out of this data. Sometimes there are also domain-specific tools that were specifically developed for this domain or this industry. So the data scientist is using his tooling, which usually always has some kind of SQL access functionality, in order to develop a machine learning model, in order to crunch the data, and in order to get insights. But this is now all on his local machine. It's not getting access to the real inflowing data stream. And that's where the loop is closed. And there are two options for closing this loop. The first option is to use our streaming analytics engine to hook into the data stream and deploy your models in the cloud. So your machine learning model is therefore directly connected to real-time data flowing in, and you can process this data and further process the results of your machine learning algorithm, for example, by creating alarms inside of Cumulocity, but also in external systems like a field service management tool if you directly want to create a ticket for someone to reach the machine. Usually that's a two-stage process where you first detect the alarm or detect the incident, the anomaly, do some remote fixing attempts with Cumulocity's advanced device management capabilities. So you try to change a parameter or you remote SSH into the machine, or you perform a firmware update or something like that. But if that doesn't work, then you create a field service ticket via, for example, one of our integrations, and you track the change inside of the field service management tool embedded into Cumulocity. But some of these algorithms work better on high-frequency data or on data that is only available locally for some reason, because you maybe don't want to upload all the data to the cloud because your bandwidth limited, or the data is really super high frequency, like sound data, vibration data, or data of that kind. Also vision data with a lot of angles on a production facility, for example, could be one of these use cases. In this case, Edge AI makes more sense. And here we support you as well by deploying the algorithm down to ThinEdge, where it can hook up in the same way to the real-time data stream. But in this case, you can have access to all data available locally. So you already can see here that some algorithms run better locally on the cloud, on the device, where you have a lot of data, high frequency, but only for one device or only for a couple of devices that are in one location. And other algorithms run better in the cloud, where you have not so much data of each device, but you have data for all devices. So comparing the behavior of different devices on different locations is easier in the cloud. In both cases, we support you and we close the loop from initial data acquisition to analysis, model creation, and deployment. And here are some examples from real customers of Cumulocity where we work together with. On the left side, you see Flexco that specialize on conveyor belts that do vibration analysis, because there are early signs by analyzing the vibration that a belt has a wear that needs to be analyzed. And this enables you to do maintenance activities at the point where you really need it. So you do not do unnecessary visits to remote locations, but you also do not come too late and replace something that is already broken. So here it's really about timing, especially for these remote areas. Then we have Wains that do pest controls. So they analyze pictures on little pest traps. So they, of course, want to analyze new insects and update these algorithms, and model deployment is of huge importance to them. And then we have Edwards Vacuum that produce vacuum pumps. And they focus also on edge analytics because they are primarily working in the semiconductor industry, where data security and privacy is of very high value. And also you have a lot of high frequency data that you want to analyze. And then last but not least, we also have a customer, Sony, who are developing sensors that are used then in diverse conditions and also run algorithms locally on the sensor itself, which is also a great way to improve data security and also data privacy by not sending the entire data stream all the time to a cloud server, but to process it locally. But these cameras are very limited in what they can hold as an algorithm at a single point in time. So you need to frequently adapt the algorithm that is running on the device in order to stay in tune with your environment. And here I've brought a video where you can actually see how this works together with Cumulocity. So we start on the training part. So here we have a user-specific training tool where you classify pictures and where you can train your algorithm. In this case, we are training an algorithm to detect cups. And this is then deployed as a module and built, but this is very domain specific. And usually that will be part of your CI/CD pipeline and automatically deployed. In this case, we are deploying it manually in Cumulocity by adding it to our software repository. So you can give it a name and a small description and deploy it to your cloud system. That makes this algorithm available in the cloud to all devices. That's just then available, but it's not yet deployed. So here we're just drag and dropping the zip file. But again, this could also be automated as part of your CI/CD pipeline, automated using GitHub Actions or similar deployment automation tool. And then once the algorithm is available, you can select a device, in this case, a camera, and select the model that you want to deploy. And by the way, on the right-hand side, you see a live stream of a Raspberry Pi connected to one of these cameras. So currently, you just see the picture, but it's not analyzed yet in any way. So it's blank. But then you can see here on the left side, the algorithm is now available. And when we activate it, then it will also be activated directly on the camera. So on the left side, we're on the cloud. We could be anywhere. And on the right side, we're on the local device. And you see, now the algorithm is deployed and it's detecting the cups. So while this is not the most complex algorithm, it shows you one of the application scenarios. So it shows you that you can now deploy one of these algorithms to the cloud. But now you want to maybe upload another algorithm and deploy it to the camera that does some post-processing. So in this instance, we upload a script that is counting the number of cups and sending this number to Cumulocity as a measurement. So currently, you see here now the rate decreased to 1. So now we have 1 cup in the picture. And if we again put the other cup out of the frame, you have 0. And then we can put them back and we have 2 again. And this is, of course, then the basis for decisions, because you can count not only cups, but also maybe hazardous situations. And with that, create alerts that in turn go to the local users, but also to remote users. And then you can use that as a basis to act on things that you detected using ML algorithms. So that's the analytical part of AI. But now with Nico, let's take a look at how the agentic version of AI can help you to further increase your business.
Thank you, Eric. So Eric now has shown you AI analytics and how it helps you basically gain insights from your data and train models based on your data. I now have the honor to speak about this fancy AI agent word. So what if AI couldn't just tell you what happened or what is happening, as you saw with the cups, but what if it could do something about it? That is the central promise of AI agents. And in this next 15 minutes, I want to walk you through what they are, how they work. I really believe, since it's a new technology, it's important to understand it in detail. And then also, how does it look like to build one in Cumulocity? And finish up also, like Eric, with some real-world examples. So what I want to first speak about is that building AI models is actually different from building AI agents. So in AI analytics, as you just saw with Eric, it's all about building your AI model that is trained on past data. For that, you have to collect data, you have to prepare it, you have to engineer your feature, and in the end, build your model, and then continually measure the accuracy, precision, and recall of this model. This is very different for AI agents. With AI agents, you don't actually build your own model. You use a pre-trained model like GPT or Claude. And what your central task is then to do is to provide this model with the relevant context so that it is able to complete a task. And deciding what information to pass on to the model in the so-called context window is your main job when you want to build an AI agent. So you can think of it like you're briefing your intern. The better you explain his task and give him the right documents and information he needs to be able to do it, the better he will perform. And that is the same for AI models. And this process is called context engineering. So today's models can handle about 200,000 tokens in this context window. This is about a book of 500 pages. And that's a lot, but it's not enough so that you can just dump any data to it, like you do for model training in the AI analytics world. And this is why you will need ways to feed only relevant data to the model based on the task that it actually is supposed to solve. And this is where techniques such as retrieval augmented generation that you might have heard about comes into play to query and inject only relevant pieces of your knowledge database or your IoT data into the context window of your model to provide it with the relevant context so it can provide your fulfill your task. And when you then evaluate the agent performance, you basically don't measure, like in the analytics world, the accuracy of the model and the recall, but you basically want to understand how well did it complete the task. And one method to do so, which gets more and more popular, is to use another LLM, so another large language model, which is asked to judge the performance of the AI agent and score it. And how do you incrementally improve your models? In analytics AI, what you just saw with Eric, you basically retrain the model with more data. For AI agents, that looks a bit differently. You need to do this context engineering again and think about which are the tasks that it couldn't solve back, what is the user feedback, do a gap analysis, and then provide it with better and more relevant context and better and relevant dynamic fetching of context. So let's summarize. In analytics AI, you train your model with past data. In agentic AI, you take a pre-trained model and provide it with the context so it can think and act intelligently. Now, I would like to dig a bit deeper even and walk you through how an AI agent does actually do this step by step. And this is a bit more complex than you see here in this slide, just giving your LLM a prompt and getting a response. We're now going to look into one of the most popular so-called agent architecture, which is the reasoning acting agent, or in short, ReAct agent. You might have heard that. And we imagine that an operator or a user asks, is this pump doing okay? And now, rather than just jumping into an answer, the ReAct agent actually instructs the LLM that you can imagine like being the brain of the model to first create a plan for answering the question of the user. And this is called reasoning. So the agent passes to the user query along with past interactions, aka the agent memory, to this large language model as additional context. And very importantly, it also tells the LLM about available tools that it can invoke to dynamically retrieve information or to trigger actions. So when the agent has done it, the LLM now responds with a plan on how to address the user question. And the LLM might also decide to act. This means invoking a tool that the agent has been equipped with. In our example of the pump, the agent could have access to a tool to query the digital twin representation of the pump. And then the agent would decide to make use of this tool to get the current state of the pump. And then this agentic framework would interpret this tool call from the LLM and inject the output of the tool call, so the actual digital twin representation, back into the context window of the model. And now the LLM observes that response, and now it can actually get into this reason, act, observe loop. So it can continue to do more reasoning steps until it feels confident that it can give a final answer to the user. And in our case, the digital twin representation of that pump might have revealed a recent measurement with no active alarm on the pump. So the agent sees this data and answers to the user that the pump seems healthy and explains this reasoning. And exactly this continuous reasoning and acting loop makes agents feel very intelligent and also adaptive to like very different user queries. And I know I already spoke about it, but let me repeat, context is everything for AI agents. And here you look at an example of a set of raw time series data. It's just numbers, no label, no context, nothing. AI analytics is great with numbers and based on past data, predict future data. Not so for AI agents. So for AI agents, such as for you, this data just means nothing. But look now what happens if we add just a little bit of context to this data. Equipment labels and units, known events like maintenance events or system failures, threshold-based alarms. And now this picture already tells a very different story. we now see that we are looking at temperature, current, and flow data of a vacuum pump. And we also see that after the maintenance, vibration and current steadily increase until reaching critical levels, which ultimately lead to pump failure. And what happens if, when we now add the equipment manual, we might learn how to resolve this issue? What happens if we add information about past incident and maintenance actions? We might learn whether a similar issue already happened in the past and how was it resolved back then. And know what happens if we now also add information about the function of this pump in the larger context of the factory. We can now assess the impact of this incident on the wider factory operations. And exactly this is the context that AI agents need to deliver useful and actionable answer. And I would like now that we have talked a lot of theory, to make it real and show you how it looks like in Cumulocity to actually build an AI agent. And I promise you that this doesn't have any line of code involved. Let me just get to the beginning. So what you see here is the Cumulocity Agent Manager. It's a no-code tool to help you build and manage your AI agents. And if you want to try it, it's still in a preview state, ping me on LinkedIn, and I'm happy to activate it on your Cumulocity tenant. You can see that I created a machine agent already. And the steps to create a new agent are very simple. You first choose a large language model, here Claude Sonnet. And the next step is to define the system prompt to provide the agent with its goals and objectives. And we can also ingest the digital twin representation of the device directly to the system prompt to provide relevant context. The next step then is to equip the agent with tools so it can dynamically trigger actions or retrieve context. Cumulocity provides a lot of default tools out of the box, but you can also integrate third-party tools that support the model context protocol, or in short, MCP. Think of it like an USB-C for AI agents. For example, here, this get context tool you see is provided by a third party and allows the agent to search the PDF operations manual of our pump. Let's now go back to our agent. For now, we don't provide it with access to any tool, and we use the test interface. So we tell it the ID of our vacuum pump. And we are now going to ask the agent about the current state of the equipment. This information it should be able to provide based on the digital twin information provided in the system prompt. But we also then ask it to check on past alarms, the equipment function within the factory, maintenance steps, etc. And here you already see the response with better information on the pump, such as model number and serial number. It shows the current sensor readings, and it also explains that there's no active alarm. However, it does not have any information on the past alarm history. No function within the asset history or maintenance steps needed, because it doesn't have access to the tools yet. And this is information that the model doesn't have. Let's now go back to the tools and provide the agent with the ability to get past measurements, alarms and events, retrieve the asset hierarchy from Cumulocity, as well as search the equipment manual. And let's now redeploy our agent. And now, instead of using the test interface again, what I want to do now is to directly integrate the agent into what we call the Cumulocity cockpit application. So we are now going to open the dashboard for our vacuum pump in the cockpit application. And I now want to create a new dashboard for our AI assistant. So let's choose a nice icon to make it look nice. And also give it a name. So I'm not very creative, so I just call it AI Assistant. And let's save it. And now we add a new widget. So our chat widget to interact with the AI assistant, the only thing we need to provide is the name of the agent, machine agent. We can now resize it to full screen, so it looks nicer, and save it. And that's all we have to do. We can now ask the agent exactly the same question. And let's wait a moment to see what it comes back with. And look at the difference here. This is what relevant context can unlock. In addition to the current state you saw before, we can now also see the recent alarm history of the pump. The agent also tells us of the function in the wider equipment context, and it gives us step-by-step instructions on the maintenance procedure, as we have asked it for. So this is just a very quick demo on how it looks like to build your own agents. So it might be less effort than you have expected. And there, thanks to the frameworks out there, is also a lot of things you can already achieve without touching a line of code. To wrap it up, I would like to speak about some real-world examples from customers we have that are already using intelligent agents within Cumulocity to solve their business challenges. So let's first imagine you're a service engineer and could just ask what happened here, like you saw in the demo, and get a full contextual answer. This is a solution that a wind energy customer of ours has built on Cumulocity. So what they have done is they have embedded a Gen AI-powered assistant directly into their platform, and their agent can access live data from the wind turbines through Cumulocity, as well as maintenance management and field service system data. And it helps the engineers to answer their question by basically transforming their natural language questions into visual reports generated with the IoT data from Cumulocity and enriched with other data from the maintenance management system and the field service system. So instead of writing a query or digging through dashboards, an engineer can just ask, what's the current wind speed at the turbine, or show me any anomalies within the last 24 hours. And the agent will then create a report visualizing relevant IoT data enriched with relevant context for manuals, policies, previous support tickets, etc. So the result, faster decisions for the service engineers, less training required, and an overall better service experience and hopefully uptime for the wind turbine. Now let's look at a second example, IoT. They are a textile machine manufacturer. They have built an AI assistant into Cumulocity that helps their end customers resolve machine issues by getting step-by-step instructions from an agent, which is fed into with information from the service manuals. So here, when an operator sees an alarm, they now don't have to go through a lot of PDF documentation or their manual, but they can just ask the agent the question and get a step-by-step instructions on how they can resolve it. But most importantly, the system is also instructed to directly link to the spare part shop for IoT to make it very convenient for the customer to order the right spare parts over substitute product from other competitors. And the result is hence not just a better customer satisfaction, but also an increased spare part revenue for IoT. So I hope that these two examples could show you what AI agents are and that they are not just futuristic concepts, but they are already adding value as of today and solving real problems. And with that, I want to briefly wrap it up. So I hope you took away from it. Agentic AI extends your AI toolbox. It doesn't substitute analytic AI with intelligent recommendations and automated actions, but they require very careful context engineering to be useful. And with that, I hand it over to Jürgen to share you how Cumulocity can help you start your own IoT journey.
Thank you, Nico. And let me share my screen. Sorry, that's coming. Okay, so now let's recap. The technical foundation you need to be successful with IoT is first, IoT data management. Yeah, there is no AI without high quality data. Second, AI analytics is there to help derive insights from structured data. So you learn from the past and predict the future. Agentic AI, like Nico explained, helps to drive efficiency with context. So there, again, super important to remember the difference, it's the context. Let's now discuss how we can help you put the technology parts into action in your individual business environment. As mentioned, Cumulocity has been in the market, in the industrial IoT market to be precise, for more than a decade. Yeah? And in the last years, we've done various projects with analytics AI. And since a few quarters, we are co-innovating with customers in the new area of agentic AI. Nico and Eric have shown to you that our Cumulocity platform is an AIoT platform. So it provides rich data ops capabilities, allows you to build AI models and also AI agents, put the context in, and manage their life cycles. But in addition to the platform capabilities, which are offered in the cloud as well as at the edge, we have a sizable professional services team that provides dedicated and deep AI skills and has implemented many of the AIoT use cases with our customers. And you can see the skills here on the slide that we have. It's just a very easy overview. You can also see the use cases that we see, and we also introduced some of them today, like Edge AI, Agentic AI, time series forecasting, Vision AI, the Sony case, and so on. But we can also do advanced things like federated learning, for example, learning on the edge. And this powers business applications like predictive maintenance, like worker safety, like building management and monitoring, or also AI-enabled customer support for machine fleets. Now, how do you get started? So if you like the presentation so far, I would like to get started with AIoT in your company. How to do that best? And the easiest way is get in contact with us. We offer fixed price discovery workshops and also POCs for you that help you understand the opportunity and quantify the benefits in your specific scenario, with low risk. So we recommend you to start small and validate the business use case first. And I think it's the biggest mistake you can do in IoT is just to get started, play with technology, and then at some point you need to scale it out, projects get canceled. You need to have a valid business case first, and we can help you to derive that before you start doing more. And then if you have a validated business use case and clearly see the value and what needs to be done, we can help you to deploy it into production and then also scale it across your global fleets, across different factories and regions. But remember, success in IoT doesn't start with AI. It starts with the secure connectivity and managing and connectivity of the devices. And that's something where Cumulocity is actually very strong. So here are a few words on Cumulocity. Cumulocity is a leader in the industrial IoT market since many, many years. And we have the most advanced device connectivity and device management capabilities. We provide that out of the box. That means without any coding. It's a self-service configurable app in our platform. And this is in use by more than 1,000 customers worldwide. And big customers like SAP, Boston Scientific, Baxter, Hitachi, Deutsche Telekom, Telstra, and you saw some more names in the examples before. We have more than 25 million connected devices out there. With connected devices, I mean industrial devices like elevators, wind turbines, compressors, pumps. And just to give you some numbers, we process more than 3 billion messages per day in our platform. We are around 300 people operating in more than 20 countries, and we have a strong partner and developer ecosystem. We have anticipated the AIoT trend quite early and have been adding strong data ops capabilities into our platform to help you unlock industrial data for smart connected products and automated operations. So Cumulocity gives you the scaling foundation that you need for your AIoT use cases, along with an experienced PS team that can provide you with guidance and consultancy. If you like the presentation, so go for a free trial or book a discovery workshop with us. But first, let's open the line and answer your questions. Thank you. Over to you, Brittany.
Excellent. Well, guys, thank you so much for such an insightful presentation. As a reminder to the audience, you can still enter questions. We'll go ahead and review a few that came through. This first question asks, how does your approach differ from other IoT or AIoT approaches, such as the ones from AWS and Microsoft?
I can take it while my colleagues join me on stage. AWS and Microsoft are certainly well-known companies out there, and they have very rich portfolios with hundreds of services out there. And IoT and AI, let's say IoT is only a very small subset of their services, but they do it. AI is much more, from my perspective, AI is much more important for them because it drives workloads, and they make their big business with the infrastructure, right? So with hosting workloads. That means AI is powering the infrastructure directly. That's why AWS and Microsoft certainly focus on infrastructure and AI more than on AIoT. Whereas our full focus, all we do with the 300 people we have and all our customers is AIoT. Yeah, it's IoT emerging into AI, and that's all we do from morning till evening. Now, from a technology point of view, to also give you some insights there, as I mentioned already, a lot of capabilities in Cumulocity are coming out of the box. Yeah, so you can get started without coding. Whereas with the hyperscaler approaches, you have to wire together a lot of small services, yeah, with coding. That's one of the basic differentiators. Maybe Eric and Nico, you want to add something?
I think very nicely stated. So we like to have our picture of an iceberg. So we provide all the stuff that is hidden under the water, but actually makes up the majority of the mass. So we provide the foundation that is more compared to what hyperscaler offers. But on the other side, we are flexible and open to build customer-specific solutions on top. And as Jürgen stated, we can do that together. That's our preferred approach, because our professional services teams, they bring a lot of knowledge and background in IoT. But of course, we are not domain specialists in every domain. So that's why it makes sense to come together as a joint team and drive IoT and AIoT together.
And don't get it wrong that our platform is also for developers, right? Yes, we have self-service tools out of the box that can be used by non-coders like business departments or OT folks. But it's extensible, like Eric said, also for developers. The ThinEdge is an open source framework that developers really love. And also in the cloud, you can develop your own microservices. What we are saying is that you should focus your developers on what really matters for your customers. So your IP, your specifics. Whereas Cumulocity provides you the standard functionality out of the box, like protocol support for MQTT or OPC UA, like a device management with software updates, firmware updates, and so on. So the standard stuff that doesn't differentiate you comes out of the box, and then you can focus your engineering and development teams really on what's making you unique in your market segment. Okay, then let's move to the next question.
Yes, thank you guys so much. This next question, did you build the AI platform from scratch, or did you leverage other products that may be best in class?
Nico, do you want to take it?
Yes, I can take it. So Cumulocity is there for quite a long time already. So it's since 2011, and was one of the, back then it was called M2M platforms, the first one. So there's a lot of technologies that we have built during that. But at the same time, we, of course, always scout existing technologies, trending technologies, and we do not want to reinvent the wheel. So, for example, looking at the whole infrastructure, we are fully leveraging Kubernetes for the whole orchestration of our services. Messaging is a very important thing, like where do all the messages get in? How can we actually scalably distribute them to whoever needs them, the application, other subscribers, etc. There we are using Pulsar, so Apache Pulsar. That's kind of a further development on top of Kafka. Also, ThinEdge is a great example. So it's fully open source. It's how you basically integrate your devices very conveniently, securely, and easily with the cloud, which also makes a lot of use of existing Linux technologies and secure modules on devices, and it interfaces a lot with standards, but adds then this convenience on top. And that is really what we try to achieve. We want to make IoT accessible. We want to make it easy. That's also our main difference approach than hyperscalers. So we do not want to build you a toolbox. We really want to lower the complexity and make IoT for the average machine builder accessible. But then, as Jürgen said, we also are aware that in the end you have your own developers working on it and customizing it and building your own differentiation. So we are also very keen on integrating with best-in-class tooling, like, for example, this whole GitOps workflows for development, like Kubernetes for infrastructure management, etc.
Another example, Nico, if I may add here, is our data hub. Yeah, this is a tool that takes data from Cumulocity and allows it to store it cost efficiently in data lakes. So there we integrate with the data lakes from the hyperscalers, yeah, and then you can use your favorite AI tools, for example, a notebook on top, or use DBT to do some transformations and so on. So you can also use your favorite tools to access the data from Cumulocity. Yeah. That's just an add-on to what Nico mentioned already. Yeah.
Excellent, thank you. And this next question, what are the biggest barriers smart equipment manufacturers face when trying to scale AIoT initiatives beyond pilots?
It's a good question from a professional service perspective, Eric, if you want to give it a start.
Indeed. So we see a lot of our customers to push proof of concept projects by themselves first, because it's easy. There's a lot of open source tooling. There's a lot of tooling provided by hyperscalers, so you can click together your own IoT solution, also including some AI features, very rapidly and with low effort. But then when customers scale, they discover that they are not a project anymore, but they become a product. And a product has a life cycle. A product has a support infrastructure, 24/7 SLAs attached to it. You have update schedules. You need to plan your downtimes. You have dependencies. You cannot just deprecate old features, but you have to provide continuity for your users. And all of that leads a lot of these customers into what I call maintenance hell. So they put more and more effort into maintenance and support, and less into feature development. And that slows them down and brings the total cost of ownership up quite rapidly. What we believe is better is exactly to focus on what differentiates you with Cumulocity, and to use the scaling capabilities and the experience that we bring to the table to your advantage. So that's, I think, a lot of that stuff that we discover. So maintenance, support, total cost of ownership increase, and all of that can be solved by using a platform. And you don't need to start from scratch again. So you don't have to throw away everything that you developed, but you can also migrate a lot of the applications and functionality that you developed on your own and bring them to Cumulocity, where we take out a lot of that stuff that really has a high burden on you, like data management, authentication, backups, and scalability of the entire solution in terms of measurements per second or data volume.
Excellent. Thank you so much. We have time for a few more questions. This next question, according to Gartner, there are different scales of AI agentic. What is the level for Cumulocity, if you're able to share?
Not sure whether I get the question fully right, but as far as I know the work from Gartner, they talk about agentic AI as a continuum, from rigid, reactive, and static agents like AI assistants, which we have shown in the demos, to super proactive, independent, evolving. What we did in Cumulocity is we enabled AI agents in a very flexible way that Nico also introduced. If we look at which is an enabler for the whole continuum. What we see currently with the customers, so in terms of adoption, is more on the first side, more on the AI agents, and we are co-innovating, like I mentioned, with customers to explore more. But let's also have a look at the entire customer base and what we see also with equipment makers out there. They are at the moment in a learning curve. They have a lot of other problems to solve first before they dive into agentic AI. So at the moment, the production use cases are still with connectivity. It's about things like the Cyber Resilience Act that needs to be implemented. Then it's about a lot of data harmonization challenges. But certainly they look ahead. And that's why the AI assistants are the more tangible piece at the moment, whereas we co-innovate and look a bit forward. But that's not adopted yet.
Maybe to add it, I unfortunately am not very familiar with the Gartner's levels of scale for AI. But of course, there are different maturity levels. I think I talked before a lot of context engineering, which I believe is the central element to AI. And of course, it gets from easy to difficult. And there are a lot of elements which are more effort. So AI assistants and the chat interfaces are the easiest one to do. But for example, at Cumulocity, we are currently also building AI in a lot of our own workflows, like building a dashboard. For that, we need to tell AI how do actually Cumulocity dashboards look like. We're putting a strict schema on it and basically educating AI also with schema validation tools to build always valid widgets which fulfill the user advantages. And this certainly requires a bit more engineering maturity, and especially this feeding the right context, but also then this AI will get you an 80% solution, but you need to think about how do you actually get to the last 20%. And this can be a lot of work if you want to seamlessly integrate it with your user experience of your product. You do not just want to give a text answer, but you want to basically have an automated mapping. You have an arbitrary device. That's one of the examples we are also looking in. And you want to basically do this whole harmonization of the data towards a canonical data model afterwards. You get an 80% output from the AI, but for the other 20%, you want this to be easy. So you need a great UI, which AI can UI, which AI can feeds in, but that your engineer can, without needing to code, can easily tweak and make better. And I think there, of course, it very quickly gets complex. However, we also believe that like playing around with this agent, it's so easy, so low threshold. You can I showed it. You can just do it. That I think in the beginning, it's really about uncovering your use cases and value propositions. And you shouldn't start with the engineering effort. You should really start with the exploration, building your agent, see if it adds value, feeding in your manuals. That is something you can do in hours. You don't need months. And then when you have a value proposition, like we talked about our wind energy customer, or Meyer and Key, then actually do the engineering investment into where you see gaps and like really say, hey, there's a valid business case. No, we can actually spend real engineering power to make this look round and really do this continuous improvement cycle. And I think at the current state, most of our customers should be really focused on this more broader discovery, trying out a lot of use cases, catching where there's value, where you can really considerably make life easier for your customers, for your own engineers. And then once you have found that, then of course it can get quite complex also with multi-agent systems, one agent delegating tasks to another agents, etc.
Excellent. Thank you all. It looks like we have time for one last question that came through. How important is data governance for your product, and how is this handled?
I really like that question because it shows that it's down to earth. So beyond all of this AI hype, we have really data. So data governance is of huge importance because no matter your great algorithms, garbage in, garbage out is still true. So what Cumulocity really also focus on is to harmonize the data. So to get data from different data sources using the protocols that the machine speaks, that the device speaks, recognizing the fact that data spaces and data structures change over device generations because machines can be in the field for decades. So we take a lot of effort into making it easy to harmonize data, to structure data so that it is available in a good way in order to feed into machine learning and AI systems. And of course, you can use AI for that. So for example, we have a mapping tool where you can map arbitrary data structures into our Cumulocity domain model and data structure. And of course, that's a task very suitable for an AI agent because it's both kind of semi-structured data and you can create the links using AI. But data structure harmonization is super important. And then going one step further, also access rights are very important because we are dealing here with sensitive industrial data. So our role-based access model that is at the foundation of Cumulocity and going through all applications and data access is fundamental to all of our AI applications as well. Because you need to make sure that only the people that really should have access also have access to certain parts of your machine. So maybe you have an electrical view, you have a deeper mechanical view, or you change your fleet into different regions, or a customer only sees the machines that he owns. So that's really data governance at its core, which is also very important in context of AIoT.
It becomes even more important if you think that many customers think about data products, going forward, right? If you want to offer a data product and maybe even share higher level services with your customers and suppliers and partners, this data governance and also the monetization around that is super critical. So that's absolutely on our high on our investment agenda. So we're still improving it, but already rigidly built into Cumulocity.
Great. Well, guys, thank you so much. That is all the time we have for Q&A, but thank you so much for addressing those questions. And thank you again for such an insightful session. This does conclude today's webinar, and I want to thank everyone for joining us for this fantastic virtual event. And thank you again to our partner, Cumulocity. We hope you enjoy the rest of your day. Thank you all again.